My name is Steven Zhao, the Technical Director of Visual Slope. In this video, I will help you to get started with Visual Slope. The first is how to start a new project. The second will how to set up a material properties and then modeling. I will use the three examples. The first one is for slope stability analysis, and this problem will evolve into a soil engineering design. After that, we will discuss how to design a reinforced slope. So let's just open Visual Slope. Once the program is opened, there are two choices. One, use existing project. You can open an existing project from the list. For our case, we start a new project. Click New and then click OK. Then the setup page will appear. So we put the title into it. And then we choose the unit. You can choose any unit you want to, as far as it's consistent. In this case, we choose the length with foot and the force with pounds. And then we decide the range of analysis. We choose left equal to 0 and the right equal to 110. And the bottom will be 100 and the top will be 160. After that, we click OK. That brings us to the main page of Visual Slope. As a good habit, we always set material properties first for the future use. So we click Material, and since there is no material right now, we click the Material button, and that leads to us to set the material. And then we choose to set soil property first. Since there's no material now, we select New. So we can put new material. For this case, we say its first one is hard clay. And the density is 115 and the saturated density is 120 and the cohesion is 300 and the friction angle is 18 degrees. For slope stability analysis, those properties are enough, and for the other analysis you may need more. It shows on the next page. We close this, the hard clay will come here, and we can save this property for future use. We open the bank and we highlight this property and save into bank. So then the hard clay will be here. We can also withdraw material from the bank for this use. So we choose Shell and then click Import. Then we have two materials for this project. And we will also need to use soil nail. In this case, we already saved in the bank. We can withdraw. I will not discuss the material properties for the soil nail. I just want to go through it very quickly so you know how to run the analysis. We can discuss the property later. For geosynthetic, we can also choose the material from the bank. So in this case, we set up all the material we need for the analysis. Then we close the material page and we will see we have two soils, hard clay, shale, geogrid, and two nails. This has set up the material properties. After that, we can start modeling. And we need to know, we need to go to model, and it shows there are two rulers. The horizontal rulers tells us the horizontal coordinates. The vertical rulers shows us the vertical coordinates. The coordinates also show at the lower corner here. And we need to draw our model in as like in AutoCAD. So the first thing is we pick up soil line, and we can either just reference the ruler, say it start 20 and 120. We can click the snap on button, so we will have 20 and 120. So this is the first one, and the next one is 40 and 120. So this is the next point. And we can also type the coordinate into the input box to draw. So the next point we will type 60 and separate with space 145. Then hit enter. So this is the point. And after that, we can do the same thing. The next one is 105 and 145. So then we will have a correct coordinate. We can also just draw it without reference the coordinate. And once we do that, we can edit the point by clicking it. So this one, we want have x equal to 60 and y equal to 120. Then we close it. It will go to that one. And this one, we want x be 80 and y be 145. And when we close, it's being set. Now we can also draw waterline just as we do for the soil. We choose waterline, and then you can draw and edit. Once you want to stop drawing, you click the right button of the mouse. The same thing we can draw for the surcharge. We have the surcharge. If we want edit a line, we can click it. This line, it will show the coordinate of this line. You can also delete this line, then the line will be deleted. You can undo it, the line will be back. If you want to delete more lines, you can use group delete and choose the line you want to delete, then the line will be deleted. And you can put it back. For surcharge, we can edit the load. We can put this into the surcharge load into it, the intensity into it, then click OK. Then the model is almost done. We need put the boundary around the model. You can draw it, or the fast way, you can use a quick boundary, and the boundary will be drawn. Then this model almost set up, except we have not signed the material. So next step is to sign the material. You click the material and move to where you want to sign. Then the material is signed. You can use the right mouse button to see the material name and the basic properties. And there are other features for the modeling. If you want to zoom in, you can click zoom in, and you can zoom in one location, and you can go back, and you can move the model vertical, horizontal, and you can move the back. You can also zoom in, zoom out with the wheel of the mouse. Once you will move the wheel forward, it will zoom in, and move the wheel backward, it will zoom out. And you can also flip the model. That's the features of modeling. After that, you may want to save the project. You go to save and go into where you want the file be saved. We say this is a video, example 1. Then this be saved. And after that, I want to show you how to run slope stability analysis. The top analysis panel shows the different analysis. Let's just do with this. We want to run a circular failure analysis, and we first specify the entry location. So these 2 points specify the entrance, and these 2 points specify the exit. Then we specify how many analysis we want to run. After that, click analysis. It's complete. There you can see this is the factor of safety, which is 0.922. This is the circular failure. Say if we want to run a block failure, how do we do that? We still use that, and we click user defined button, and then we draw the lines from which we will form a failure surface. So this specifies the failure surface we want to. The beginning and end point should be beyond the slope a little bit. Then we click analysis. The analysis is complete, which is 0.939. That's the user-defined failure surface. If we want to run a block analysis, we can specify more failure surfaces. Say 300. The width will be 1.5. We run analysis again, and we'll see those are the failure surfaces, and you will see the blocks are generated at the end of each line. and you can see the different ones, and you can see all of them if you want to. Alright, so this tells you how to run a visual slope for circular failure and the block failure. Next one, I would like to show you run a composite failure. For example, this is a soil and this is a rock. The failure surface may not necessarily be inside of soil. It may follow the interface of soil and the rock. So how do we do that? What we can do is we draw a line. We call it the limit line around the soil and rock interface. And we can also consider reduce the strength of the interface. We click that and choose the limit. Before should be 1, and we choose to 0.7, which is 30% lower than the soil material around this interface. And we go back to the analysis and we choose a little bit more, and here we choose 300, and then we pick up composite shape, and after that we run analysis again, and you will see the failure surface will from soil and slide around the rock and then go around soil, which gives you another failure surfaces like that. This is a composite failure surface if you need to run. Since the factor of safety is below 1, this piece of soil may fail. To stabilize it, we can add soil nail in. So we take the limit line out, delete it, and delete this one, and we draw soil nail, and say we have a free end first. Draw 2 lines there, and then draw the grouted section in. And we need to assign the material properties for the nail. So we go to the material and we assign nail 1 to this, nail 2 to that, and then we have the nails draw in, and then we run analysis again. So we choose circular and we put this a little bit further, and then we run analysis. Now the factor of safety is 1.2 after 2 nails were put in. So this tells us how to run a slope stability analysis with soil nails. And let's do something further. We can delete the nails, Instead, we add GeoGrid into this piece to see what happens. Since there are many GeoGrid, we can draw in or we can generate. Let's generate it. We put the generate in. First, we choose the material, and then we give the start elevation, which is a 1.121, and the end point is a 144, and the vertical space, we choose a 1 foot, and the length, which is 20 feet. And once you do that and click OK, then the GeoGrid will be in, and then you can run analysis again. So this gives you a factor of safety of 3.37. It's much higher than the original one. You can also run analysis around the GeoGrid for see the direct sliding. So you choose that and then run analysis. Once it's finished, and you will see this is the sliding over the GeoGrid. So this tells us how to design a reinforced slope. So with this example, we know how to run slope stability analysis, soil engineering design, and reinforced slope design. I hope these will help you to learn how to use Visual Slope. Thank you very much.